Assalamualaikum. Today I want presenting my review titled A Review Report on Pathogen Isolation and Antimicrobial Susceptibility from Microbacterium BINTI. I'm Safiqa binti Safinoruddin from Bachelor of Applied Science in Fisheries. My supervisor is Professor Dr. Muhammad Effendi bin Abdul Wahid. Okay, for my introduction, Microbacterium BINTI is the largest genus of the family Phalomonidae. Giant freshwater prawn live in freshwater. This is this species is high commercial value in food source and valuable export product. This species is native to Malaysia and other Asian countries. Doing early diagnosis are important for monitoring the health status of farm species. Disease and mortality problems are caused by pathogens. Among infectious disease on prawn including white tail disease. Typical symptom of disease Microbacterium BINTI is weakness, aggregation at the site of spawn and rapid growth. Antimicrobial susceptibility is used to prevent infections and disease caused by pathogens, not damage the host, and inhibit the growth of microorganisms. Antimicrobial resistance is not killed by the drugs and cause effective for medications used to cure the infection. Antimicrobial susceptibility, if bacteria are susceptible, can be treated with the drug. My problem statement is poor management of water quality, such as the drug abuse can cause the infection and of pathogen on dire freshwater prawn. Next, health of dire freshwater prawn largely depend on water quality and presence of pathogenic disease. After that, lack of source and article publication of antimicrobial susceptibility of pathogen isolated for Microbacterium BINTI. One significance of study is to learn that Microbacterium BINTI cultivation using healthy practice is no drug abuse practices. Next, to ensure the shrimp is free from antibiotic residue by reflecting the result of antimicrobial susceptibility test, and to add more information on antimicrobial susceptibility in Microbacterium BINTI aquaculture. For my objective is to review the drug abuse and excessive antibiotic uses in dire freshwater prawn farms, and to review antimicrobial susceptibility of the bacteria isolated from Microbacterium BINTI. Next, to review the approved antibiotics to avoid drug residue. For methodology, first the strategy, second study selection, and third data organization and reporting. First, search articles from database namely Google Scholar, Scopus, Find Direct, Visiscape, Elsevier, and Spring Domain. I use keywords such as antimicrobial susceptibility and giant freshwater prawn. Articles were chosen by screening the title, abstract, and took the full article from the database research. Only papers that published in English were accepted. Information sites from each study were organized particularly according to the data about the pathogen isolation and antimicrobial susceptibility from Microbacterium BINTI, experimental method results after flow and years of publication. Antibiotic in shrimp feed. Antibiotic feed at low, usually subtherapeutic concentrations are reported to enhance the productivity and therefore performance of feed conversion in food-producing animals. A broad variety of antimicrobial compounds, including oxytetracycline, ciprofloxacin, nitrofurantoin, furazolidine, and chlorphenicol are used in hatcheries and farms of giant freshwater, prawn, and marine shrimp. Previous studies show that the MIC range of ciprofloxacin is at 0.32 to 0.43 mgl for successful control of Vibrio and Aeromonas species, much lower concentration than other antibiotic studies. Persistence towards antibiotic in shrimp. Based on article reported 95% bacteria resistant to oxytetracycline and 90% bacteria isolate from larvae and post-larvae of giant freshwater prawns show resistance to oxytetracycline, erythromycin, and furazolidine. Vibrio strains are mostly susceptible to nitrofurantoin, azithromycin, and sulfametazole. Regulations: the uses of antibiotics in prawn farms due to the risk of developing resistant bacteria. When the bacteria have developed resistance, it is difficult to get rid of them with antibiotics that antibiotic for treatment arise various antibiotic-resistant bacteria. The resistance was transferred to pathogenic bacteria and decreased the efficiency of antibiotic treatment for disease caused by resistant pathogens. Antibiotic residue in shrimp. The antibiotic chloramphenicol and nitrofurans are banned worldwide for use in the food production due to their serious side effects and cause fatal aplastic anemia, and nitrofurans are listed as carcinogenic. The ampicillin-resistant trend may be due to the fact that first-generation antibiotic is misused in the environment, thus minimizing the susceptibility and efficiency of ampicillin in the treatment of vibrio infection. The use of oxytetracycline has resulted in increased bacterial resistance in shrimp farms, and similar increased resistance to chloramphenicol has arisen through misuse of antibiotic in shrimp hatcheries. Solution for antimicrobial resistance in shrimp aquaculture. First, fish health specialists should provide guidelines on the amount of antibiotic to be used, the frequency, and duration. Most bacterial infections can be treated with a single antibiotic. Manage the water quality to maintain dry freshwater farm health. Use the approved antibiotic and susceptible antimicrobial to pathogen to avoid drug residue. Minimize the use of antibiotics through the biosecurity measure. Good hygienic practice in shrimp aquaculture and introduction vaccine for biotic and effective microbial. For my conclusion, this review shows that antibiotic-resistant bacteria are prevalent in the shrimp aquaculture. Susceptible antimicrobial effectively control pathogen at an invaluable protection and a little treatment to avoid drug residue. For my recommendation, first preventing and controlling bacterial disease in aquatic organisms is important. Then, the overuse and misuse of antimicrobials in aquaculture should be reduced. This is my reference. Okay, that's all from me. Thank you.